All right, in this problem we have a description of a circle, and we want to write its equation, its standard equation. Okay. So remember from the last video, there's three things that you need to write the equation. You need to know the horizontal and vertical position of the center, so basically the coordinates of the center, and you need to know the radius. Okay. And so if we read the description, it says the point 4, 1 is on a circle. So it's somewhere on the perimeter or circumference of the circle, and the center is 1, 4. Okay. Write the standard equation of the circle. So the information that we're missing here is the radius. We don't know the length of the radius of this circle. Okay. All right. So let's write kind of the generic formula, right? X minus h squared plus y minus k squared equals r squared. Okay. And then I go to my description here and I'll label what I know, right? So the center of the circle is 1, 4, right? So that means 1 is the horizontal position of the center, it's the h value. 4 is the vertical position of the center, that's the k value. Okay. What we're lacking again is the length of the radius. Okay. So here, why don't we try to add a visual here? So let's just draw an x and y coordinate. 1, 2, 3, 4. X-axis 1, 2, 3, 4. Y-axis. Everything's positive, so I think we're good there. All right. So the point 4, 1 is on the circle, and 1, 4 is the center. So let's write that as the center. Okay. So if I, if I had I wish I had like a string, which I could extend here and then whip that string around, right? That would give me the shape of the circle, right? So the circle is going to look something like that, right? So we know one point on the edge of the circle, and we know its center, and all these other points would be the same distance. Okay? So the question is, what is that distance, right? That's the radius. Okay. And so you might not see it yet, but I'll make it a little bit more apparent to you that we have a right triangle. Okay. And the length of the two legs is 1, 2, 3 units there. The length of this leg is 1, 2, 3 units there, right? So how do we find the radius, right? The hypotenuse of this triangle? We use Pythagorean's theorem, right? A squared plus b squared equals c squared. Okay, so we could write over here, let's move the paper over, 3 squared plus 3 squared equals r squared. Okay, so that's 9 plus 9 equals r squared, or 18 equals r squared, or r is equal to root 18. Okay. And for those of you who want like a decimal value, the square root of 18 is about 4.24. 4.24 is the approximate length of the radius. All right. So that was the only piece that was missing, and so now we can substitute the h value, the k value, and the radius into our formula here. All right, so let me replace the letters h, k, and r with just empty placeholders. Right, x minus h squared plus y minus k squared equals r squared. Okay, and then the h value is 1, the k value is 4, and the radius, okay, now I have a couple options here. I can write it as a decimal, or I can write it in radical form. Radical form is going to be best because I know that square roots and the second power cancel each other out. They're inverse operations. Okay, so that's going to help me out when I'm, clean this equation up. Okay, all right. So the first term is basically just x minus 1 squared. The next term is y minus 4 squared. And then root 18 squared just becomes the integer 18. All right? And so there we have the equation of our circle. Okay, so we had to do a little bit extra work in calculating the length of the radius ourselves, and we used a visual to do that. Okay, but that was really the only new layer to this problem, right?